In this video, I'm going to be talking about the discriminant. The discriminant describes how many x-intercepts a certain graph will have. And more specifically, a quadratic can have three different sets of x-intercepts. So if we were to look at these three graphs here, they each have a different number of solutions, or in other words, a different number of x-intercepts. The first graph on the very far left, has two x-intercepts, or in other words, it has two solutions. The one in the middle has only one x-intercept, or just one solution. And the quadratic that's on the very far right graph has no x-intercepts, in fact. It has zero solutions. So just looking at this, those are the three different types of graphs you can have. But how do we infer how many x-intercepts a quadratic equation can have just by looking at the equation and nothing else? Not by graphing it, not by sketching it, just by looking at the equation. That's where the discriminant comes in. The discriminant is a nifty formula that looks like this. So the triangle denotes discriminant. This is what your discriminant is. Discriminant, I ran out of space. And that is what's equal to the following formula. Your discriminant is simply equal to b squared minus 4 times a times c, where b is the coefficient of x, a is the coefficient of x squared, and c is the constant. Your discriminant is this following here, and the discriminant will be equal to a number, let's say 6, or minus 7, or 0, or 12. It can be anything. If your discriminant is more than 0, that means your equation for the quadratic will guaranteed have two x-intercepts. It'll have two real solutions. If your discriminant, however, is equal to 0 after you work it out, that means your graph has just one solution. And if your discriminant is simply less than 0, ta-da, you have no x-intercepts. That's how your discriminant can tell you which sort of graph you have. So now, enough chatter, let's go through a few example problems. I'd like you to work out how many x-intercepts does this following equation have? No sketching, no graphing, just looking at the equation here. Well, first let's work out the discriminant. The discriminant is simply b squared minus 4ac. The value for b in this question is the coefficient of x, which is 2. So it's 2 squared minus 4 times the value of a, which is the coefficient of x squared, or minus 4, times by the constant, which is minus 1. 2 squared is equal to 4. Minus 4 times minus 4 times minus 1, that's just equal to 4. So this whole thing simplifies to 4 minus 16, which is just equal to minus 12. So because the value of our discriminant is equal to minus 12, we know that that's a number that is less than 0. That means our quadratic will have no solutions. It'll have no x-intercept. Let's work on to another one. I'd like you to work out how many x-intercepts does the following equation have. No graphing, no sketching, just using the discriminant. Well, the discriminant in this case is b squared, which is 2 squared, minus away 4 times 3 times by 5. That's equal to 4 take away 12 times 5, which is 60, which is equal to minus 56. And hence, because the discriminant is less than 0, we know that there are no solutions. Next equation is this one here. What is the discriminant for this function here? The discriminant is equal to minus 1 whole squared minus 4 times minus 1 times minus 1. This is the same as minus 1 squared, which is 1, minus away minus 4 times 1, which is just minus 4. That's equal to minus 3. Again, discriminant is less than 0, hence there are no solutions. What about this equation here? Okay, how many x-intercepts does this equation have? Well, discriminant, that's the same as 8 minus 8 whole squared minus 4 times 3 times by minus 7. 8 squared is the same thing as 64. Minus away 4 times 3 times minus 7, which is minus 21. And 64 times minus away 4 times minus 21, that's the same as plus 84. And this here is simply equal to 148. Because the value of your discriminant is more than 0, your quadratic will have two solutions. It'll simply have two x-intercepts. Next one. How many does this equation have? Discriminant, that's equal to 8 squared minus away 4 times 2 times minus 7. This is the same as 64 minus away 8 times by minus 7 is just minus 56. So minus away minus 56 is the same as plus 56. This is the same as 120. Therefore, because your discriminant is more than 0, you will have two solutions. The next one we're going to work out is how many does this equation have? Discriminant equals 2 minus 3 whole squared minus away 4 times 6 times minus 2, in which case minus 3 squared is simply just 9, minus away minus 24 times by minus 2. That's equal to plus 48. And the quadratic discriminant is simply equal to 57. Therefore, say it with me, discriminant more than 0, therefore we have two solutions. What about if we have an equation like such? What about if we have an equation that looks like y equals to 8 minus 3x minus 2x squared? Do not do the following. Do not do this. The discriminant is not the same as minus 3 squared minus 4 times 8 times minus 2. Okay, in this case you can do that. Okay, but what happens if your equation was rewritten as such? Oh my goodness. Okay, if we write it like this, okay, our discriminant will be misled into believing that it's simply equal to 8 squared minus 4 times minus 3 times minus 2. We cannot do this. This is illegal. Okay, if we have our quadratic written like this, we still need to remember that the values that go into our discriminant is still whatever a, b, and c are respectively. Okay, whatever a, b, and c are. In this case, a is not equal to 8. A is the coefficient of x squared, which is minus 2. Okay, so we need to rewrite it. Discriminant is minus 2 whole squared minus 4 times the coefficient of x, which is minus 3, times by the coefficient of the constant. In this case, the constant is just 8. Minus 2 squared is 4. Minus 4 times 3 is minus 12. In this case, minus 4 times minus 3, which is 12, times by 8, which is 96. So 4 plus 96. That is the same as 100. Say it with me, discriminant is more than 0, therefore there are two solutions. Okay, another trick you can use is you can work out if your discriminant is a perfect square. In this case, the square root of 100 is simply equal to 10. That means your two x-intercepts will simply be whole integers, which means your entire quadratic is just a perfect square. So that's a very nifty trick you can use. Next question. This time, we're going to use the discriminant to work out values of an integer. So the question that we have here is if we have this equation here, we have the equation 5x squared minus 5mx minus away m equals to 0. We need to work out the values for m for which, so work out m for which part A, it has no solutions, the quadratic has no solutions. Part B, the quadratic has one solution. And lastly, the values for m, not x, for which there are, the the values for which there are two solutions. Pause the video and give it a go yourself. Well, to solve this equation, to solve the values for m, we need to employ the discriminant. The discriminant in this equation, we need to be very careful. The values for a, b, and c are simply still the coefficients of x squared, of x, and the constant, respectively. The coefficient of x squared is 5, the coefficient of x is minus 5m, and the constant here is just minus m. So let's work out the discriminant. The discriminant is the same as minus 5m squared minus 4 times 5 times minus m. This means, if we were to expand it out, that is the same as 25m squared minus away 20 times minus m, which is the same as plus 20m. Now, our discriminant doesn't equal to a number, it equals to an equation. So what the hell do we actually even do here? Well, what we can say is our discriminant, if we know there are no solutions, that means our discriminant will simply be less than 0. Our discriminant will be less than 0. And in order to work out and solve for this, we're going to graph the equation of our discriminant. So the first thing we're going to employ is, looking at the discriminant here, let us simply simplify. First off, we know that 25m squared plus 20m must be less than 0 because the discriminant must be less than 0. So by factorizing, we can say 5m and we can have left 5m plus 4 less than 0. So in graphing this quadratic, what I can recognize is we have two x-intercepts. Our x-intercepts are when 5m is equal to 0, so we're using the null factor law. 5m equals to 0, in which case 5 equals 0, and 5m plus 4 equals to 0, in which case m is equal to minus 4 over 5. So I'm just going to sketch this out real quick. So we have two x-intercepts there, and we're not really too interested where your x and y intercepts and the accuracy of the graph. We just want to have a rough graph like this. And this x value here is minus 4 over 5. This x value here is 0. Well, if you want your discriminant, you want the value of this equation to be less than 0, that means the graph itself is below the y-axis. It's below where y equals to 0. So what we really want is we want to work out when is this graph less than 0. It's less than 0 for this interval here in green. For that interval there, the discriminant will be less than 0. And all I can recognize here is that's just in between the two x-intercepts. It's not equal to the x-intercepts, it's in between them, because if it was equal to the x-intercept, that means our discriminant equals 0. But we don't want that, we just want to be less than 0. So what I can say is the discriminant is less than 0 for the values between minus 4 on 5 and 0. And that is the solution to part A of this question here. Now let's do part B. For part B, we need to work out what is the value of m such that this quadratic has simply one solution. In other words, when is the discriminant just equal to 0? Well, we have the graph of the discriminant, and when is that equal to 0? It's equal to 0 for the values of which it's lying on the x-axis. So the discriminant graph is lying on the x-axis. And it's lying on the x-axis at the x-intercepts. It's lying at minus 4 and 5 and 0. Hence, by the way, I made a mistake. It's meant to be for the values of m. We're solving for m here, not for x. So that means for part B, m can equal to minus 4 and 5, or m is equal to 0, because that's when the discriminant graph is actually equal to 0. Last but not least, we need to work out for what values of m does your discriminant make it more than 0, because that's when you have two solutions according to the discriminant. Well, all that means in this graph here is when is the quadratic above the x-axis. It's above the x-axis for the red regions right there, and I'm going to make it permanent. It is for this section of the graph, as well as this section of the graph, for which the discriminant is more than 0. The left part of the graph can be described as any x value that is simply less than minus 4 over 5. So that means this region here is when m is less than minus 4 over 5. And for the right side of the graph, we can say that this region is simply any part of the graph where the x value, or in this case the m value, is more than 0. Where m is more than 0. So those are your two solutions for part C. You can say that m can be less than minus 4 over 5, or m can be more than 0. And those values, any values for m that are less than minus 4 over 5 or more than 0, will satisfy an equation at the top here for which that solution has two solutions, two positive or negative real solutions. And that's how you use the discriminant.